And what I'm showing is from the notes from the last time we met. But what I did recently to kind of try and clean up the project is I met with Riff and we went over quite a few of the items where maybe those items might not be needed anymore. Kind of wrote down the reasons why, and I'll go ahead and get those closed. And I'm marking those as done this week as I go through. But there were, a couple of them were like this enforced connection rate limit per ENI that we thought was such a great idea way back when we started the group. It turns out, like, for example, this one just might not be implementable in the behavioral model because I put the notes down at the very bottom. Um, you know, because behavioral models technically to ensure correctness of the transformations, not to target the high throughput scenario. So we thought that it was okay to close this one, but we did go through a few of these. That's this one, and then connection tracking in the simulator. We thought maybe it would be handled by the new Flow API and data plane app, this one here. And then fragment handling here, we had talked about, this is a long time ago, but we had talked about how to handle fragmentation in the behavioral model. And we talked and thought that it should be handled by, the NIC itself with the pipeline. So I was thinking to close this one. And then, we were also looking at doing a comparison between Open Contrail for flow tracking, and we thought that this would be maybe covered by the new incoming Flow API doc, which was the same as the one up here. And so this is kind of the work I've been doing here to get this cleaned up. Was there any questions on this part so far? And so,
Hey, Christina, on the
yeah.
fragment handling,
Uh-huh.
I not, it's not clear to me what it means to say the NIC handles it.
Okay. And we do not have a method to obtain the correct hash. So we're talking about how the L4 header isn't there when we're trying to look at the fragmentation. Is that right, Riff?
Yeah. So what the how should I say, like the so basically in the fragmentation here is a IP fragmentation. So basically send say if we have like a TCP packet and it is jumbo. And then what happens is that it breaks down to, let's say, 2 IP packet. So the second packet will not have the TCP header, so it will not have the right information. So essentially what happens is that the second packet, we will not be able to actually do the 5-tuple hash or get into the right queue or something like that. So it is a generic problem that in the Azure networking. So basically, if you say let's because if you see a lot of like the services or data path services, for example, like DBTK applications that have like RSS and everything. So basically, if we support Jumbo, like the sorry, not support Jumbo, I mean support IP fragmentation, then the second fragmented packet will not be able to steer to the right queue, which will not be handled like correctly. So, which is why like the one of the things that we just say, okay, let's just don't support the jumbo. Oh, sorry, let's don't support fragmentation. Let's just make the jumbo bigger. This is how the fragmentation versus jumbo, and which is why the fragmentation support is not really have to be there in the dash. So that's my understanding. So, I'm not sure if that makes sense.
Yeah, I mean, that was my understanding as well, that like there wouldn't be L4 information in the
Right.
non-first fragments. So I mean, I think the PR here was, I mean, I haven't reviewed it lately, but what I recall was that it was talking about, do we have to handle that case? I mean, if we just declare that, fragmented packets we drop, that's fine. That's fine to me. I don't want to add more complexity than necessary. But I mean, one possible solution, depending on the DPU, is that you could do like virtual reassembly, like buffer
Yeah,
the fragments until you had the whole set, and then you
yeah,
would know how to do the hash lookup on all the fragments. Then you release them. Like
right.
it's possible to do that. It's
Yeah,
complicated to do that. If we're
right.
declaring we don't need to do that, I'm fine.
Yeah. So, yeah. So basically, I think that's where the notes was taken is like a Nick handles the fragmentation is a fragmentation like offload. If I remember correctly, that is a
Mhm.
fragmentation offload feature that a lot of Nick actually supports today. So essentially, like DPU is actually also contains the functionality of the NIC. So if the ASIC can handle then like the, picking up the fragmentations, I think that will be good. But from my current understanding is that the fragmented packet is not really guaranteed to work. So yeah, but I can double confirm with this like the IP fragmentation like requirement and come back later.
Okay. Yeah,
Yeah,
I
I
mean, if
mean,
it comes down to they really don't work in the whole network, like at least this
yeah,
network, then we don't need
yeah,
to make it more complicated.
yeah. It's like some part of networking may work, but some other part may not. So
Yeah,
yeah, this is why like when I see it's like okay, maybe we can make something work, but some other part may not work. So does it really like
yeah,
worth doing it or not? Yeah. But on the other hand, is like on the behavior model, it's probably really hard to do that. So
that is, yeah, it's probably extra hard to do in the behavioral model. Yeah. Oh, wait, so
right.
when you say the NIC, are you talking about like a part of the DPU, or are you thinking about a different device in the network?
It's a part of a DPU. So it's actually the
Oh,
DPU contains usually contains the functionality of the NIC. So
so maybe I missed it, and I'm sure I missed it, but what do you mean by fragmentation is the functionality of the NIC? I mean, what is it that the
uh,
NIC is doing? Is it
uh,
doing reassembly before doing the hash and all
right.
that, or?
Right. So usually
Okay,
a lot of like smart NICs today already supports. I think a long time ago is already supporting like a fragmentation reassembly.
right, okay.
So it's a fairly frequent seen
Typical.
feature or normal feature. It's not difficult. It's like a normal feature for a lot of smart NICs today.
Well, I mean,
So
it's functionality is not difficult, but you still need a lot of buffering for any of that
right.
stuff. So that's why I'm
Yep.
curious that they do it. But okay, thanks.
Yep. That's true. Thank you.
okay, so this is a little bit
Yeah.
different than I was thinking before. So you're saying like fragments may exist in the network, but when the fragments get to the DPU, there's a portion of the DPU which you're calling the NIC, which will do the reassembly before it gets to the like programmable pipeline part.
So that part I'm not super sure, but because this one depends on vendor's implementation, so I'm probably not the best one to answer that question. I'm just saying like the reassembly the fragmented packet is not something new. Like yeah. Um,
I mean, the
Christina,
pipeline.
Christina,
So
do you mind to put? Oh, sorry.
no, good.
Oh yeah, I was just asking like Christina, do you mind to put a work item on me to close the requirement so we actually can have the requirement like documented, so then we'll make the more clear.
So close this one, but then open a new one for this piece, the fragmentation requirement.
Sorry, just to close the requirement, like to confirm the requirement for the fragmentation handling.
Yeah, I have that here, but did you want that in this issue or open a new issue?
Yeah, this issue is perfect. Yep, just
Okay, I'll
tag
just
it.
tag you
Yep,
there.
thanks,
Okay.
thanks so much.
Okay.
I mean, so you get the choice of doing the reassembly before hitting the pipeline, which makes more sense to me because if the pipeline has to handle fragments and all that, I mean, it's huge in my opinion. But
Yeah.
I guess that's
Right.
what the requirement definition is about: is do we reassembly then go to pipeline, or do we handle fragments through the pipeline.
Yeah, and if we do the reassembly, so some network like service devices do like virtual reassembly where they figure out like all the fragments and gather them together logically, but they don't actually reassemble it into a single packet. But then they can do processing on all the pieces. If we actually do like real reassembly, like a NIC on a server would for like packets that are being received, if those are reassembled, then we'll probably find that the packet is too large again, and we'll have to fragment it. Because like if we're sitting on a smart switch, so that's just another thing to consider. If we do want to support fragmented packets, are we doing virtual reassembly, physical reassembly, and then physical fragmentation again?
Mhm.
So.
Okay, so I'll tag you there, Riff. Thank you.
Thank you.
Yeah.
Well,
and
actually,
then, go ahead.
just a quick side note on what Bud
Sure.
says, like the transmit fragmentation, it's actually depend on the transmit interface, right? So if you receive a bunch of fragments, you still, regardless of the pipeline or whatever, you're still gonna have to, once you get out of the port, you're still gonna have to check the MTU and make sure that you fragment properly and all that jazz for that interface anyway, right? Regardless of how the packet came in. Like even a real packet, like if you receive MRU, if your MRU is 4K, for instance, but UTX is only 1500 bytes, you're gonna have to fragment or something, right?
Yeah.
But for the smart switch use case, isn't the switching ASIC taking all the pain of fragmenting? Why it will fragment towards the
Well, I guess that's the question here: is where is fragmentation and defrag and repackaging happens? Is it totally outside the pipeline or not?
But is it even a requirement given that, like Grep is saying, right, fragmentation usually doesn't work in the network and most people just configure the network for jumbo packets. So
if you receive a fragment packet, what do you do with it, I guess, is also
I mean,
part of the requirement.
No, but if it's Azure or something, then they know that they're sending fragment packets out or not, right? I mean, I understand if it's like internet or something, then it's different because you don't know who's sending the packet to you. But if it's cloud, then the cloud providers know usually whether they support fragments or not.
But I mean, aren't some of the cloud functions like accepting packets from like the internet in general?
But that won't come to the DPU, right?
Well,
if it
in
did,
Azure,
Yeah.
for example, we do allow some fragmentation, and the customer has to go to the support portal, open a ticket, and then that ticket goes to we call it the host networking queue that works with VFPGFT, who's doing basically what we're trying to do as well. And they they configure that a little bit differently for that customer's ticket. I mean, that's what we do. Yeah.
I mean, in general, in cloud scenarios, I don't think fragmentation is a big deal, probably, because I think they set the MTU to a point where, and I think it's going across the network in their fabric seamlessly, right? But I mean, I think that's generalization of that comment. But in general, in cloud scenarios, that may not be needed. But in specific application scenarios, NAT and other things, maybe it's more prevalent. I think the reassembly or fragmentation, virtual reassembly, like you were saying.
Yep, and that is the one I'm going to confirm. Is there any like very specific scenario that we need to take the IP fragmentation into consideration?
Yeah, but cloud scenarios generally are controlled networks, and I think the overhead there is maybe not needed. But if it is not, in other scenarios, we'll need to understand. Yes.
Right.
Okay,
Right, sounds good.
Thanks for offering to look that up, Riff. we had a couple to check on. Ashutosh, with this one, were you saying this one I can now close because you created the programming for inbound?
Yeah,
Yeah, I can close this.
yeah, we can close this
Okay.
one.
I'm gonna do that. So I'm just gonna put that in the done this week. Great. And then this one. This was
Yeah.
failed to add the default route withdrawal action, but no next hop. I think we were gonna look at this if we had time. Yeah, let's skip this one because I need to research it a bit more.
Yeah, I looked at it before and it wasn't even clear to me if the
Yeah.
operation being done was a legal one.
Yeah.
Yeah.
Okay. Let me look at this add-on miss one because we thought that it might be covered by the new work that Riff's been doing here, and
Yeah, I
that's
think this one can be covered. Yeah.
with the software agent under dev. So is it okay to close this one then, or should I leave it open until we know that for sure?
No, I think we will know this for sure. Like this one will be solved, and actually soon, as we probably can see, like in the PR, there is a Flow API. So probably in a 2 weeks ish or 1 or 2 weeks ish, we can actually like present an API.
Okay.
So eventually we can use an API to create those flows to fill in the add-on misgaps.
Okay. So I can close this one.
Yeah, I think so.
Okay.
Not sure if yeah.
I'll leave it open. It's okay. That's okay.
Yeah, not sure if anyone else thinks differently, but
Yeah.
it feels like
What do
it
you
should be
guys
covered.
think? Yeah.
I mean, yeah, if the BMV2 will not implement it, then I think we can close it.
Okay.
Unless we want to rename it and say, but I think the notes already say that it will be superseded by DPDK. So
Okay. So this one we were supposed to talk about in the behavioral model meeting because it's a big, or the work group, because it's kind of big. If you guys remember the this match type here. And so this guy wanted a workaround, and oh, so Marian thinks he fixed it. Unsupported match types are excluded until they're not supported in the simulator. Go ahead, sorry. We cannot fix this issue by taking the first item of the list to BMV2. It's done in Psi. Psi API takes it will not fail. Sounds like I can close this one.
So
yeah,
one thing, one thing
sorry.
to say is that I think the issue wasn't fixed. It's just that we put FTF around it.
We've put what around it?
We put a Band-Aid on it.
Yeah.
Band-Aid.
Yeah.
Okay.
Yeah. So basically, I think that's it's a small typo. So it probably was saying like we can, not we cannot. But yeah, we put a Band-Aid on it. It's like we take the first item on the list and just put that item in there. The other way, I actually for the echo probably not. There is no the other way, but yeah, actually yeah, there is no other way.
So no, that is right, Riff. But one more thing which I pointed out is that if you look at the -ACL.p4, we basically marked that test match entry with an optional attribute. And I think because of that, when you generate the Psi API, that match key is not there in the API. So the API doesn't even have those keys. So we should replace that optional with a single entry.
Oh, really? Okay. I probably can take a look at it. Actually, do you mind to send me the the name of the key? I can definitely look it up.
Yeah, just look at the -ACL.p4 and I will send you the link. Yeah. It's basically all the match key, the source port, destination port, source IP, and dest IP. When I looked at the generated API a few weeks ago, all of them were not there, and the ACL only had a ENI as the match key. And because we marked this as optional for BMV2, but for but before DPDK, we marked it correctly. But for whatever reason, for BMV2, it was marked as optional. So I'll send you the link.
Okay, sounds good. Yeah, somehow remember the reverse way, but I see. Okay, I see that. Yep, thanks.
Okay, I'm gonna leave that open then.
Mhm.
If that's okay, yeah.
Yep.
Yeah.
Yep. Thank you.
Yeah, no problem. And so I think I wanted to ask Mircha about this, or the hairpinning. I guess our question was, will the smart switch use case remove the need for the hairpin? And we were doing hairpin with the appliance version, if you guys remember. And
Yeah, so one thing I
Yes.
wanted to understand for this one, right, is
yes,
that you're right about that with the smart switch, the underlay routing will be done, but it will be done by switch, I think, not by the DPU.
yeah.
So in the behavioral model, do we want to include the switch functionality also, or is it just the behavioral model of DPU?
Sorry, I'm just rereading this real quick. So BMV2 ignores and sends out on the same interface. So this was about a test that we weren't sure was working. Real hardware with 2 ports is the requirement for a packet to come and go. So for smart switch, I just don't know if we need that anymore.
Yeah, so the problem here is this, like that if you
Yeah.
want to do complete underlay routing in the behavioral model, right?
Mm-hmm.
Then we need to implement the complete SI pipeline with, the next hop group, next hop, neighbor, router interface, all those objects. And we don't have that today in Dash.P4, so the corresponding APIs are not generated also. So there's currently no way to really program the proper underlay routing in in the behavioral model. In the actual hardware, the routing will be done by smart switch, I think. Sorry, the switch or NPU. So you will probably get the correct behavior because the NPU will expose those APIs for programming the underlay route.
Mm-hmm.
But the DPU will not.
Right. So do we still need to do this in the DPU? Like, I'm just trying to think of the kind of tests we would do with a standalone DPU, say inside of an appliance versus a smart switch. Of course, my preference is because I work on smart switch. I would just worry about smart switch. But what do you guys think? So in the appliance, what we have is basically a server with 6 DPUs inside of it, and no switching ASIC.
Yeah, so
I prefer to have it, especially if we go appliance and other use cases which have more than one port. I would prefer to have it, but and this is why we made the PR for it.
Yeah. Okay.
no, but
And so, but it's quite a bit of work.
yeah, right. That PR doesn't do the complete routing functionality, right? And I think Chris had put that comment, maybe somewhere, maybe on a different issue, right? So we cannot program it the way you would program a typical underlay routing pipeline, right? Because there's no neighbor object, there is no router interface object, right? So when you call those APIs, let's say in the test or something to program the underlay routing functionality, the underlying tables are not there in before.
I see.
But that's why in my PR, right, and this tries to the ref about the PR I opened, right, and you said you'll review it, right? And we had to comment out the underlay routing programming from the test because for me to program those, I need to have a neighbor table in the behavioral model, right, and a router interface table. But those are not there in our behavioral.
I see. The thing is, and if we leave it over there, will it cause any problem?
But then we cannot set the MAC address because the test does is that it goes and programs a MAC address in the neighbor table, but then there's no neighbor table. So How does how will the BME2 set the correct MAC address? So when the
I
packet
think for
comes out,
the
it doesn't have the correct MAC address, right?
yeah
And that's why the
because we
test was
don't have
failing.
but the test didn't. Will the test fail? Because previously it's also like MAC address is all 0. But the things that we're not checking the MAC address. That's my understanding.
No, so the problem was that all the tests were commented out. So they had a skip if in front of it, saying that since underlay routing is not supported, these tests were commented out. So just because underlay is not there, the overlay functionality was also not getting tested, which is wrong, right? We should at least test the overlay. Because that's kind of the main purpose for Dash is the overlays, right? The primary reason, right, for writing this test.
Right.
So what I did in my PR is to comment out the underlay, which is not programming, which is not there, and at least get the overlay tested, because all those tests are today getting skipped.
I see. Maybe I missed some part of the code, because I thought the overlay it is tested.
No, the test is there, but there's a decorator, Python decorator there saying skip if, and so the test has skipped. If you run the regression right today, the CI pipeline, and if you look at the log of the CI pipeline, you will see they're all getting skipped actually.
I see. Yeah, because I remember I changed something like before and break the test. So you might understand the test is always wrong. So this is why I probably missed some of the things in your PR. But let me check them again. Yeah.
Yeah.
Okay.
And in order to make the underlay work, so what we need is actually the route next hop member. Next hop group, next hop member, and next hop.
And neighbor and router interface.
The routing interface and what's the final one? The
neighbor.
Oh, neighbor. I see. Okay. Oh, that's actually will be
neighbor here. Yeah, here.
I mean, the two issues, right? First, you will need it, and the second is that you don't want to generate those SCI APIs from the P4 code, because those SCI APIs are defined in the SCI repository, right? So we can't use the generated API.
There.
Yeah, so, actually, on that last point, we found a solution to that when we added the very simple what's it called, next hop table that's currently in there, where you can just select a port. It's kind of a trivial implementation to support some of the testing that Murch's team wanted to do.
But it doesn't set the port. So Mac, that's the problem. So it does set the port, right? So I'd
like to finish. We found a general solution to allowing predefined SCI APIs that are already defined in SCI repo alongside Dash generated code, and they're not completely mutually incompatible. So you could write a backend handler to deal with let's say hard-coded SCI APIs, and the way we did that was by looking at the P4 annotation, I believe, to decide if it had dash underscore in the name, and if it did, it would generate the dash, code and callback code, and if it didn't, it would assume it was SCI provided libraries, right? SCI provided headers, sorry. And so if we wanted to create implementations for the back end for these other tables, it could be done. The API generation wouldn't conflict. I'm sorry I didn't, let's say, express that in the most articulate way, because it's been about a year and a half.
Yeah.
But if someone wanted to implement, a back end that made it look like it was handling the SCI underlay, we could do it in the P4
you can
and the
skip
callback
that part, but you still have to implement the pipeline, right?
Oh yeah. You could.
That's what I'm saying. So there are two issues. One is to implement the pipeline, and the second is to not generate the APIs from
to wire
pipeline.
the plumbing. Yeah. So I was talking about the plumbing part. The P4 part is definitely still there.
So so the two things, right? So yes, we should do that, right, at some point. But what I was asking Riff is that while that is not there, should we not even? At least we should get other tests going. right? Because
Yeah, I think I missed
automatically
the
everything
skip
getting
if.
skipped. Yeah.
Yeah, I missed the skip part. So I already put change. So I was like wondering like, oh, I commented out or the test was wrong. So yeah.
Okay.
Yep. Sounds good.
So leave this one open then while we continue to think about it.
Yeah, probably need some investigation to see how to make this one work.
I don't even know who James is anymore. Oh, I remember James. Okay. All right. Great. And then we also
And-
wanted to talk about use cases for sequence. Oh, go ahead, Chris. Sorry.
Oh, I just said hi to Andy. He just popped in. Long
Oh,
time no
hey,
see.
hey, hello. Welcome to the scintillating conversation around BMV2 P4.
I'm had another conflicting meeting, so
It's okay.
So-
That's okay. Yeah, I was simply going over the ones that I've closed because we may not need them anymore. We'll have a Flow API doc and we'll have potentially a software app. So we went through those and then we started looking at the use cases for like that basic underlay routing in BMV2. And now this one we're talking about the sequence number tracking and connection tracking and whether we think we'll need it or if we have a use case for it. So like this one, and we were to discuss it here for a use case, because we were talking about if we were tracking sequence, we wouldn't have fast path anymore. And every packet would need to update the flow entry where the states are stored and then we thought, well, we'll just bring it here and talk about it. Do you remember, so this was a while ago, but Mario from AMD was thinking that we should track sequence numbers and acts in the messages. Do you guys think we have a use case for that?
So yeah, so is this something that first of all, is it a requirement from Microsoft to track sequence number, right?
I think, at the time, oh, go ahead, Riff, sorry.
Oh yeah. So the use case for sequence number tracking is actually for is actually for like a reset on time idle timeout. So basically, whenever a flow is gets closed but gets timed out, and at that moment, we will need to actually send a reset packet to both sides to say, hey, the flow is gone. Please, like the reset packet, because essentially the the dash is the main in the middle. So yeah, that's the only case we'll use the sequence number tracking. But to implement the sequence number tracking in PMV2 or in Dash behavior model is actually really interesting, because that means that every packet we need to go through the slow path. Yeah, yes. So maybe some ASIC has this capability, but in the behavior model, it basically means that the fast path, the so-called fast path, will still need to go through certain like data plan app gets the flow updated with a new sequence number. But yeah.
So let me see if I can understand the desire or requirement you're saying is that when a flow state has been idle for some configurable time, let's say 2 minutes, whatever.
Yeah.
At the time that it's aged out, you want to be able to generate reset packets to both ends.
Right.
And so if the fast path had a capability to generate an event on an age out of a table entry, that might help the fast path do it, but some paths might not be able to do that. Is maybe the sticking point.
Yeah. So there are two things the fast path needs to be able to do. The first thing is that it needs to update the sequence number like directly inside of a data plan. Well, ideally. The second thing is that, of course, when at timeout, when you send a notification, I think this one PLA already have it. But the changing the fields inside of a data plan, if I remember correctly, is not there yet in any of the behavior model, like the architecture. So yeah.
So the sequence number tracking is for, you're saying, recording the sequence number of the last packet received and then checking for each
Right.
received packet whether it's within some window of that last one. That's a
Yeah,
dash
yeah.
requirement
So
to do that checking.
yeah, yeah,
on every packet.
on every packet. Yeah. So basically, if a
Yeah,
packet
which
hits a
means
flow,
somebody has
then
to track it and store it, right? Somebody has to keep tracking and keeping the state of the last node in the connection tracking module or the part of the pipeline. Somebody has to keep track along with the states of the connection. Along with that, you have to track the sequence number now, right? That's the extension needed.
Yeah.
So that's something that.
So
Yeah,
Rip, right? Let me just be clear on this one. So I'm not asking about behavioral model. I'm asking about the real hardware, right? So you're saying that this is a requirement to track the sequence number and then generate a RST packet with proper sequence number when the flow expires.
Yeah, at a certain moment, this will come. But right now, I think the things like the private link is not required. So at least this one is not required. But in other scenarios, yes. So
what about VNet to VNet?
VNet to VNet, this is actually a good question. But I'll come back. I'll come back on the very like the confirmed answer later. So yeah,
Sure.
yeah. But for
Thanks.
PL, it's not required. So I listed very explicitly over there. So yes.
Yeah, I think just in general, like writing the flow entry for every packet is kind of expensive. I think probably in every architecture.
Yeah.
Yeah, this is a super expensive piece of work. Yeah, for sure.
Yeah. Which is the reason I explicitly mentioned that. Sorry, it's not required. Good.
Yeah, and
Maybe it could be
also
a
to
capability.
generate a on a flow expiry for hardware to generate RST packet in both direction is pretty complicated requirement.
Yeah. So the packet generation is well, I guess it depends on the implementation because it could be like hardware just sends flow expired like notification out, then the software generates packet, sends to the pipeline. Yeah. So, but eventually the sequence tracking may not be ideal to send like every packet to the right. Yeah. Although it's doable in behavior model, but in the real implementation, it's probably not that ideal. So yes.
So Christina, can you add that ref will check it for VNet to VNet case? Is it a requirement or not? Because I think we understand PL doesn't need it, but VNet to VNet is sort of bread and butter. So.
Sorry about my handwriting there. Okay, sounds good.
Thank you.
So Rip, do I assume that for now this is a lower priority ask, right?
Yep.
Well, it's low enough. It's low enough priority that it's number 196, which was from a while ago. But but we do have to address it at some point and kind of come to agreement. Riff wasn't here during 196. I think Riff joined around the 400s.
That's fine. Vintage 196, well aged. We'll break out some cheddar cheese to go with that.
Sorry for the comedy.
Circa 2022.
So the question is, do these age like cheese, wine, or fish?
Oh God, fish if it's 196.
Or house guest.
What's that, Andy?
Or like house guests.
House guests.
Like
fish.
That's a synonym for fish.
Yeah. Well, we only have 2 minutes left. Maybe we could just cover this last one around, Mario. Oh, another Mario special. But he wanted support for write back table entries. And I need to know, is this a duplicate of item 12? So do we still feel we need these table entries? Let me look. Connection where an entry is connected first active, track a connection, entry corresponding needs to be. Okay. So I think that the subject's pretty clear.
Is this similar to the sequence
The-
number tracking?
Yeah, it's similar to 196. It says that
I think it could be used to implement sequence number tracking in BMV2. It's also more general, I think. It could be used for
Yeah,
other
yeah.
sides.
okay,
Yeah,
right back
basically
in.
updates. Yeah, basically updates any any field in a for a table entry in the data plane directly.
Okay. Directly. We'll come back to this one another time. Okay. All right. Well, that's really all the time we have for today, unless you guys want to bring anything up.
So it's good scrubbing.
Oh
session.
yeah. Well,
I'd like
and
to
now
talk
that
about
we
IP fragmentation some more. No, I'm kidding.
yeah, well, no, let's talk about active HA and PSI APIs. Just
No, I
kidding.
have this bike shed design I want to go over with you guys.
Okay. Yeah.
Andy liked that one.
What color?
So go ahead.
Exactly. That's how it begins.
So stop the recording.